Welcome to Additive Guru. My name's Samantha Godsey, and I'm a mechanical engineer here in the lab. And today we're going to talk about how to get this look on your part. This organic look is a geometric pattern known by several terms. Some people like to call it a lattice structure, some people prefer tessellations, and some people call it the Voronoi diagram method. So let's learn more about who Voronoi was.
Georgy Voronoi was a Russian mathematician that died at a young age of 40 in 1908. His specialty was the geometry of numbers. Today, that research has widespread application in areas such as spatially distributed data, geophysics, and in meteorology. There are several beautiful homages to Voronoi tessellation, including a landmark building in Leaderville, Australia. So why apply this structure onto our part models? It's more than aesthetically pleasing. These tessellations use less material, reduces the weight of our part, and can meet a variety of our design objectives. For example, we have an entrepreneurial client that is developing a hybrid hydroponic system. Inside this system, we need to meet the basic needs of a sprouting seedling. We needed a little spot for the seed to nest, a way for new roots to reach the nutrient-rich water down below, and lastly, imperial data dictates that we provide for air circulation for a healthy, moist growing environment. We began with a simple seed pod, and right away you can see our limitations with this cone. We could hack away at it in the model space and carve in some clunky holes, but not only is it not attractive, it was a frustrating, time-consuming process, and it only meagerly meets our objectives. However, using more elegant design components such as a lattice structure, we can quickly produce a beautiful part for our client. Let's see how we accomplish this. Welcome to the model space. This is Meshmixer. We've imported an STL file, a simple cone made in Fusion 360. We won't go into making it here. You can use our other tutorials to assist you in the design. It's just a simple cone, 2 millimeters thick, and here in Meshmixer we'll be using two functionalities, Sculpt and Edit. Let's start with Sculpt. In Sculpt, we'll use brushes here at the top. Select the Reduce brush. This will cause our mesh to be coarser and less dense, creating a foundation for our tessellations. Careful now with the rims at the top and the bottom. We don't want these areas to become too thin. Use a slider to choose a smaller and a larger brush, and then click over the body of your part to apply. Rotate and apply to the sides and the back. With this simple shape, it isn't necessary to flip it over and do the insides. Alright, now that will do. Let's go to Edit. You may have guessed there isn't a handy Voronoi button here either. However, there is a pattern that's going to help us out. From this drop-down box, we're going to select Dual Edges. Apply this dual edge pattern to your solid model, and you'll see how it's brought this coarse mesh out that we created in Sculpt out of the solid body. Accept these changes, and we'll fast forward here while Meshmixer calculates triangles. Wonderful. Here's our new solid model with our coarse mesh applied. Now before we leave the space, let's use an additional function to help our downstream flow processes of slicing and printing. See these red dots? These indicate problem areas. Meshmixer has a neat fix for these. We're going to use the inspector and allow Meshmixer to auto-repair our model. This will fix the holes in the intersections of the tubes, helping to ensure a printable file.
Here's our seed pod printed on an FDM printer. It's easy to see how this will meet our client's needs beautifully. It's a simple, organically designed part that has a place for our sprouting seed, allows roots to grow and air to flow. And as an enhancement, we printed it in algae, so this adds an environmental friendliness angle to our client's marketing strategy. Thanks for joining us, and we'll see you next time.